In this video, we're going to talk about an important technique called rationalizing. So you've probably heard or been told that you always have to rationalize the denominator. Because that's a very common thing in high school. What that means is that your denominator has some sort of root in it, and we want to write it so that it doesn't have a root in it. So rationalizing means making it have no rationals. So no root, no rational exponents, so no roots. To do this, when it's a square root, we want to multiply, well, for some of them, I guess, we want to multiply what we call the conjugate. Okay, so the conjugate of the expression a plus b is just a minus b. Okay, so you just change the sign. So if it's a plus here, then you want to write a minus here. If it's a minus there, you want to write a plus here. So you just switch the sign in between them. So the conjugate of 2 plus 3 root 7, I would write both things, okay, the 2 and the 3 root 7, and then I just change the sign in between them. Okay, so because it was a plus, now it's a minus. Okay, the reason why we want to use the conjugate when we're dealing with square roots, and in particular binomials that have square roots, so things that are two terms with addition and subtraction, where one or both of them have square roots, is because when I multiply by the conjugate, which I'm actually going to do here, something nice happens. Okay, so if I wanted to multiply these two terms, so 2 minus root 3 and 2 plus root 3, I have to use what we call FOIL. So I have to do the first two, and then the outer two, and then the inner two, and then the last two. Okay, so this is first, outer, inner, last. That's how it spells FOIL. So you should be familiar with this. So 2 times 2 is 4. And then I'm going to have plus 2 times positive root 3. So that's plus 2 root 3. And then I'm going to have plus negative root 3 times 2. So that's negative 2 root 3. And then I have plus again, but it's minus. It's going to be a minus because of the minus here. So it's minus root 3 times root 3. So that's minus root 3 times root 3, which I wrote out a little bit. Okay, so that's 4 plus 2 root 3 minus 2 root 3, because plus and then a negative is just a minus. And then here this is going to be minus, but then root 3 times root 3 is just 3. Okay, it's root 3 squared, and then they go away. Okay, now the nice thing is these middle terms that have the square roots in them cancel, because we're always going to get one of them with a positive, the same thing, okay, but one of them with a positive and one of them with a negative. And then so I just have 4 minus 3, which would just be 1 here. Okay, so that's why it's because of this this part here that they cancel out, is why the conjugate is so useful, because I'm always going to end up with something that doesn't have any roots in it. Okay, so let's try an example. So let's say I wanted to rationalize this denominator. And I should have mentioned up earlier, we don't have to always rationalize a denominator. So in our class, sometimes we're going to want to rationalize the numerator. Okay, this is just a trick we have to rewrite an expression. So sometimes it will be useful to rationalize the numerator. Okay, but here we're going to do the denominator. So I have negative 1 divided by root 2 minus 1. So what I want to do is multiply by a fancy 1, that's the conjugate. Okay, so the conjugate of the bottom is going to be root 2 plus 1. So whatever I want to multiply on the bottom, I have to also multiply on the top. Okay, so this is my fancy 1. So I'm multiplying by 1 here, which doesn't change my expression. Okay, so that's going to be negative 1 times root 2 plus 1. So that negative has to go through. And then I'm going to expand the bottom. So let's just write it out. Okay, now you don't have to always write all the steps here. I'm going to talk about that after. Okay, so on the top, it's going to be negative root 2 minus 1. Okay, and on the bottom, I'm going to have So the first ones is root 2 times root 2. Okay, that's root 2 squared. And the outer one is going to be root 2 times 1, so that's plus root 2. And then the inner ones is negative 1 times root 2, so that's going to be negative root 2. And then the last ones is negative 1 times 1, so that's negative 1. Okay, now again, root 2 and minus root 2 is 0 root 2's, so those go away. And then I have negative root 2 minus 1, and then root 2 squared is just 2, so then I have just 2 minus 1 on the bottom. So, which is, again, just 1. It doesn't always turn out to be 1. I don't know why I picked 2 examples that did, but so then this is negative root 2 minus 1 over 1, so it simplifies to negative root 2 minus 1, because dividing by 1 doesn't do anything. But when you have, so if you want, when you have, like, I don't know, I'm going to write it simply, but say root of, so something like what we had, root of a minus b times root of a plus b. So when you times it by the conjugate, it's always going to be the root of a squared minus b squared. So it's going to be a minus b squared. Because the middle terms are always going to cancel out. So this term is root a plus b, and this term is root a times minus b. So those ones are always going to cancel out. So it's just the first ones minus the last ones is what you're always going to get. So if you don't want to always do the FOIL and you want to remember that, that's okay. But doing the FOIL doesn't take very long. Okay, now these type are a little bit different. I mean, I guess this is still, you could think about it as a conjugate, but you don't have to. So when it's just one thing on the bottom, okay, so for the square root, so here you have to do them a bit differently, even though they look quite similar. So for the square root, I know that if I times it by itself, that it's going to disappear. So I want to times the bottom by root 3, so I have to times the top by root 3. And that's going to be 4 root 3, and then root 3 times root 3 is just 3. So we're done already. So this is much, much easier. Okay, now this one is maybe a little bit harder because I need to remember that cube root of x is x to the 1/3. So if I times it by itself, I'm just going to get x to the 2/3, which is still a root. Okay, so I don't want to do that. I want to times it by something that's going to make the exponent an integer. Okay, so it's going to be x to some power, so I want x to the 1/3 times x to the something to equal x to an integer, which I'm going to write the integer as, pick integer 1. It's probably the nicest integer. Okay, so then over here, I should have left myself some more room. But this, because we're multiplying with the same base, is 1/3 plus the question mark. So if I want that to equal 1, then I need my question marks to equal 2/3. Right? Because 1/3 plus 2/3 is 3/3, which is 1. So what I actually need to multiply here is x to the 2/3 over x to the 2/3. Okay, so that's going to give me 2x to the 2/3, and then down here I'm just going to have x to the power 1. Okay, maybe I should write that out. Well, I just did down here, so that's probably okay. But it's x to the 1/3 plus x to the 2/3, which is x to the 3/3, which is x to the 1. And then if you wanted to write this using roots again, this would be 2 cube root of x squared over x. Okay, either of those is fine. Those are the same. But yeah, you have to be, when your root is not a square root, you have to be a bit more clever, and you want to pick a power of that thing, the appropriate power, to make it an integer. Okay, so it's not always just the same thing. In fact, it's usually not, unless it's a square root. But it's going to be with the same bottom. Okay, so the root makes it 1/3. So this thing is definitely going to be over 3, and I want to pick a top that makes it, when I add it to 1, that makes it a nice multiple of 3. Okay, so that's how we rationalize.